So, there's a little note talking about what part of the curriculum this is or isn't part of. Don't worry about that part of things. Instead, here we go. Investing money. If you deposit money in a financial institution, such as a bank, you are in effect lending money to the bank. In exchange, the bank pays you. The word you can underline is interest. There are two types. Simple interest, which actually is almost never ever used, but everything starts with it, because everything else is derived from it. And compound interest, which really is used almost all the time. Simple interest is usually applicable to short-term investments of 1 year or less. Or honestly, if you're loaning money to a friend or you're borrowing money from a friend, they might charge you simple interest. Or to long-term investments where the annual interest is paid to the investor and not reinvested. And it goes like this. This is going to be Math 8. Suppose you invest $500 with an interest rate of, all of us please underline 6%, just to get you in the habit of looking for the rate. But you also have to look at what the terms are per year. How much would you earn in 1 year? Pardon me? How would you calculate it? First of all, I'm going to write it out in English. Don't write this down. You would earn 6% of, don't write that down, 500. In half a year, you would earn 6% of 500 divided by 2. Don't write that down. In 1 month, you would earn 6% of 500 divided by 12. The reason I said don't write that down is, this is what you're going to write down in just a second. We never do math with percentages. We always change them to decimals. So the first thing, and I hope you can do this in your head, 6% is what as a decimal? So this you can write down 0.06. And the word of almost always means multiply. You can write that down. In other words, what I would write down, if I want to find 6% of 500, it's 0.06 times 500, which is not 60 bucks, 30 bucks. So if I earn 30 bucks of interest in a whole year, what would I earn in half a year? Please do this in your head. 15. What would I earn in 1 month? 30 divided by 12. I think I can do that in my head. It's going to be 5 divided by 2. It's $2.50. Double check me. Yeah. What if they said per day? How would I convert this to days? Instead of dividing by 2 for a half year, instead of dividing by 12 for months, what would I divide by? Guys, you with me back there? You good? How would I go from years to days? Divide by what? 365. Yeah, well, it's not going to be a significant amount. Let's generalize. If R is the annual interest rate as a decimal, and P is the initial investment, by the way, the reason we use P, the word for the initial investment, and you'll see this in finance, is called the principal. L-E or E, principal, I think it's L-E. No, it's A-L. I should have got that. How would interest be earned? Well, you would go like this. R times the principal. 0.06 times 500, but it's traditional Mackenzie in the formula to put the amount in front. So I'll do it in that order. Half year. Well, really, you're going P times R times half a year, because that's what you did when you divided by 2. For T years, it would be P times R times T years. For 4 years, you'd times by 4. For 8 years, you'd times by 8. And this gives us our simple interest formula. The interest is PRT. I equals PRT. I will give this to you on a test. You won't need to memorize it. But you'll need to memorize what each of these things means. I is the amount of interest in dollars. P is the principal, the initial investment, or if you're borrowing, the initial loan. R represents the annual rate of interest expressed as a decimal. And T represents the time in years. Now, this is important. If they give me an interest rate per month or per day, I'm going to have to convert it to an annual rate. We'll talk about that. Millie invests $2,350 at 7% for 6 months. Calculate after 6 months the simple interest. It's going to be like this. I equals PRT. I equals PRIT. Where P is the principal. Brendan, what's the principal in this investment? I know I caught you zoning out, which is why I picked on you. What's the principal in this investment? Psst, look up, 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 look up. So more specific, what's the principal in this question? More specific, what's the principal? Can you say it with authority in your voice, like you're paying attention and know what's going on? 2,350. Brandon, I'm going to pick on you again because you're really zoning out. What's the interest rate as a percent, first of all? 7. Is it per year? So we're okay. Change 7% to a decimal. What's 7% as a decimal? 0.07. Okay. And then T is the time. How long is the time in years? It's 6 months. What fraction of a year is that? Can you guys crunch that? How much interest will she earn in 6 months? Get a question? Question? Might have been good. No, not now. It's going to be far less right now. Right now, it's a good time to borrow. It's not a great time to invest. But you're going to find we keep the numbers fairly middle of the road because interest rates fluctuate, and that way we're always at least kind of sort of close to what they really are, maybe. We won't go too big or too small. Just a dumb trick. So it's going to be 2,350, clear that. 2,350 times 0.07 times 0.5 and $82.25. B. Oscar, what's B want me to find? What'd she start with? Oscar, what'd she start with? How much did she earn? You know what? The value is going to be the principal plus the interest. That's what it's worth now. Can I do this in my head? $2,432.25. Someone double check me. Yay. Having said that, Ashley, no one does simple interest. Compound interest is when they charge interest on the interest. And that's what they do. Which is great if you're investing. It's not so good if you're borrowing. So, for example, on my car loan, which was a 5-year loan, the first 3 years I was only paying off the interest. I wasn't even paying off the loan. Because they're charging compound interest. They're charging interest on the interest. Or in a mortgage, a 25-year mortgage is fairly standard. Probably the first 16 or 17 years, you're mostly paying off interest, not the loan itself. Now, interest rates right now are low enough that probably my numbers are off. Probably now you're not having to pay for the interest that much. It's a good time to borrow. So, in simple interest, the principal at the beginning of the second year is the same as the principal at the beginning of the first year. In compound interest, the interest earned during the first year is added to the original to form a new principal. And now, well, you know what? Let's look at an example. Next page. A bank offers 2 types of savings bonds. A regular, which gives 9% PA is the abbreviation for per annum. Annum is the fancy Latin word for per year, and they use it in finance. So you got 9% per year simple interest. Can we all underline simple interest? Or a compound savings bond, which pays 9% per year compounded annually. Let's look at the simple interest. The simple interest each year is 9% of, hey, what does of mean mathematically most of the time? What should I do? Multiply. It's 9%, 0.09 times 15,000, 0.09 times 15,000, 1350. Which means each year we go up by 1350. 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 In other words, the one that comes after 21,750 is that 23,100. If I'm really clever, now what I'll do is this. Answer button plus 1350. 24,450. Answer button plus 1350. 25,800 is the final value of the bond after 8 years. Compound interest, we're going to be doing a lot more number crunching because each time the interest is added to the principal and we start over. In other words, in year one, at the end of year one, to calculate how much it's totally worth, it's the original amount plus the interest. There's a 15,000 here, there's a 15,000 here. That's a GCF, a greatest common factor. I can factor a 15,000 out, and that leaves me with a 1 plus 0.09. You can make a little note here. This is year one. End of year two, what you would really have is the original amount plus the interest plus the interest on the interest. That's why there's two 1.09s here. In fact, after year two, you would calculate it by going the principal times 1.09 squared. End of year three, it's going to be the original amount times 1.09. Spot the pattern. What exponent do you think is going to go on here? After year two, what was the exponent? A 2. After year one, what was the exponent sitting right there? After year three, what? Pam, sit up, kiddo. Okay. After year N, it's going to be 15,000, 1.09 to the nth power. This is our generalization of compound interest. Okay? I'm going to skip right down to year 8. If I want to know what on compound interest this is going to be worth, it's going to be 15,000 times 1.09 to the 8th power. It's going to be 15,000 times 1.09 to the, and you need to know where your exponent button is, to the 8th power. Is this worth under compound? Is this investment worth more, the same, or less than the original on simple interest? I got 29,800. Oh, for money, we always round to 2 decimal places, Julia. So this is going to be $29,888.44. 2988844. Compare that, if I scroll back, with 25,800. Grayson, compounded, because you're getting interest on the interest on the interest on the interest on the interest from year to year, this person makes over $3,000 more. Or if it's a loan, pays more than $3,000 more. Okay? It wants us to plot the data. I'm going to skip that part. All I'm going to say is, for what it's worth, simple interest forms a straight line. Compound interest forms an exponential curve. Matt, what does every single exponential curve look like? Compound interest does that, which means the longer you have the loan, holy smokes, the more you're paying off. Or the longer you have the investment, holy smokes, the more you're making, because it gets steeper. It gets steeper. Page 502, you can skip that. Blah, 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 blah. What I want to get to is page 503. It turns out we have this. You can write this at the top of the page. For simple interest, the interest equals PRT. And Mackenzie, that will tell you the interest. If you want the total amount, you'll have to add the principal on. The compound interest formula gives you the total amount. The formula is as follows. A for amount equals the principal times, in brackets, 1 plus lowercase I to the n. Yeah, it's the same formula that's down the page here, but I always have kids just write it out so they can see how it's put together. Now, why is it this way? You guys stay on this page. I'm going to scroll back. So this is what we were doing here. We were taking the original amount, the principal, that's why there's a P in front. Why is there a 1? 1 as a percent is 100% of the original amount, along with 9% extra. That's why it's 1.09. How many times was the interest charged in 3 years? 3 times. That's why there's an exponent 3. How many times was the interest charged in 8 years? 8 times. That's why there's an exponent of 8. The compound interest formula, you won't need to memorize this. I'll give it to you on a test. But you will need to memorize what everything means. Final amount, A, equals the principal times, in brackets, 1 plus little I to the power of n, where little I is the annual interest rate. Actually, we're going to modify that in a bit. And n is the number of years. And n is the number of years. Example 2. So, let's do some examples. Suppose we have $4,000, and we're going to invest it in a 3-year GIC. What's a GIC? Something investment certificate, I think. Government investment certificate. It's a bond. All of us right now, please, can you underline the word compounded? Come back. Can you underline the word, the phrase compounded yearly? That tells you this is compound interest. And underline the rate, 3.5% per annum. We're going to use this. A equals P bracket 1 plus little I to the n. But in part A, we're going to, my Physics 12 kids will recognize the acronym DFIC. We're going to list our data. What's the principal in this question? 4,000. What's the interest rate as a decimal, please? 0.035. Right? What's n, the number of years? 3. So if I want to find out how much this investment is worth, after 3 years, it's going to be, and I want all of you to try typing this on your calculator so you know how your calculator works. I tend to add the 1 to the decimal in my head. I know that 1 plus 0.035, Rachel, is just 1.035, and it's going to be to the third power. So make sure you know where your exponent button is. Try this on your fancy schmancy graphing calculator. Do we have our book here there, Giancarlo?
No, I looked it up.
Oh, boy. I'll look forward to seeing the notes filled out on Monday. I get 4,000 times 1.035 to the power of 3. Okay. By the way, compare that, Darian. If this was simple interest, it would just be 0.035 times 4,000 times 3. I would only earn $420 as opposed to $434.87 extra. 443487. 4434.87, and I'll put a dollar sign in front because that's bucks. Ah! No. Okay, here we go. You needed that. I know my aim was a bit off, but it got you. You're good. Okay. Example 3. Rihanna has invested $8,000 in a 5-year bond compounded annually at a rate of 3.2% per annum. Find the interest. Okay. Compounded annually, I'll underline that, and the rate is per annum, 3.2%. So the equation I'm going to use is A equals P bracket 1 plus little I to the N. Try this one on your own, please. Try this one on your own. I'll freeze the screen so you can't just copy. Oh, one too many zeros. That would have been bad. How many of you got that? You're wrong. What did this question want me to find? The interest earned. What did she start with? $8,000. What did she end with? $9,364.58. How much of that was interest? Subtract. Okay, so read the question carefully, Carson, after you put your phone away for the remainder of class. You guys okay with, Alyssa, how I got the 1,360? I just went final amount minus principal. Okay. So this equation actually calculates the interest and the principal, gives you a final amount. That's why we put an A here for amount. But in our simple interest equation, we put an I there because all it gets you is the interest, and you got to add it to the amount yourself. Turn the page. Amber invests $8,000 in an investment for 5 years. I'm going to underline the phrase compounded annually because that's what tells me to use compound and not simple. And it's a rate of 7.25% per year. says determine the value of her investment. Well, A equals P bracket 1 plus little I to the N. I think the principal is 8,000. Mac, what's the interest rate here as a decimal? 0.725. Oh, if you get that investment, sink everything into that investment if you get 0.725, because that's 72.5%. I would take that rate of return a million times over. What is 7.25% as a decimal, Mac, my friend? So 1 plus that is 1.0725. What's N, Mac, in this question? Okay. 8,000 bracket 1.0725 to the fifth. Do you get $11,352.11? No, am I wrong? Yeah.
No, it's
11,352.11 for part A. Ben, what's part B want me to find?
Let's calculate the profit.
Oh, what's the profit? You know what? That's another synonym for the interest. $3,352.11. Is that okay, Rach? Okay. But now let's start to actually do some financial planning. Suppose she's not sure how long she wants to leave this money in the investment. Suppose she wants to see how this changes over time. She can graph this. So it says in part C, write an equation in the form y equals ab to the x to represent her balance after x years. It's going to look like this. Where the a goes, I'm going to put a y. What number is going to be in front of the exponent? What number is going to be in front of the exponent? What number is in front of the exponent? 8,000. What's the base? What's the number underneath the exponent? More specific. I think it's this, isn't it? I think it's this, isn't it? 1.0725. Now, instead of putting this to the fifth power, to the sixth power, it wants us to just to generalize, so that's where I'll put my x. This is what we're going to type into our graphing calculators. So get your graphing calculators out if you haven't already. Go into your graph menu, delete any graphs that are there. And now, Oscar, we can do a little financial planning. The equation that describes the value of this investment, and again, I can't use A's and P's and I's, I have to use X's and Y's, that's what my calculator got. It's going to be 8,000 times bracket 1.0725 to the power of what? That's where the X is going to go. Nice yawn. That's the equation that's going to show me the value of this investment, Grayson, as time changes. This is going to help me do some financial planning. They gave me a view window to use. They want me to use an X min of 0, an X max of 10, scale 1, and a Y min of 8,000, a Y max of 18,000, and a scale of 1,000. I got that right from the window. Brendan, she needs your help. Your eyes were closed. You're awake? You're sitting up? I'm going to, you really want to sit up, kiddo?
I know. I have migraine and my body.
Okay. You need to tough it through, my joy. You can do it. So you see, guys, we've seen these view windows before, right? It's always min, max, scale, X first, then Y. This should give you a nice little graph that you may have seen in some financial movies or banks or something like that. In fact, you know what, Matt? I can tell you what this is going to look like. It's an exponential graph. You know what every single exponential graph looks like? Yeah. What? By the way, if it's growing, When the economy is collapsing, this was the 2008 when the world economy, it would look like that. Okay? What do the numbers on the x-axis represent? What does this here tell me? And your hint is, look at the units next to it in the actual question. Years. You know what? This represents time in years. What does the y numbers represent? Well, the y is sitting, right where the a was sitting.
Value, overall value.
Final amount or value. Okay? It says Amber Lynn wants to know which of the following options are better. If she starts with an extra $500, or if she can invest her initial amount but at 8%. So this is a little financial planning. Which one's better? It says for each of these, write an equation to represent her balance after X years. Okay. Let's draw the line like this. Let's do the 8% one first. I think, Alyssa, that equation would be final amount equals still the same initial amount of 8,000, bracket, but instead of 1.0725, if we're at 8%, what's going to be in the bracket? 1.08. And to the n years, to the x years. Now, Julia, on my graphing calculator, that was a y and that was an x. Or I could start out with more. I could have final amount equals an initial amount of $8,500. But still, Brendan, at 7.25%, 1.0725 for, we're not sure how many years. Oh, let's put an n here. And again, I recognize that's going to be a y, that's going to be an x. And part F says, graph both equations at the same time. Okay. I can do that. I'm going to delete equation 1. And for equation 1, I'm going to type 8,500, bracket, 1.0725, close bracket, to the x. And for equation 2, I'm going to type 8,000, bracket, 1.08, close bracket, to the x. She can either start out investing more, or she can earn more along the way. Which one's better? That's the question we want to ask. Let's keep the same view window. Which one's better? Depends when. Just so I can get a feel, I'm going to toggle this graph off. Draw. So here's the first graph. The second graph is the one that, you know what? It doesn't earn as much for the first while. That 8% doesn't earn as much for the first while. But right around here, it catches up and it starts to do better. So the answer, Mac, here, like most of the time in finance, is, Grayson, it depends how long you're planning on leaving it in for. Any ideas on how I could find the magic sweet spot? It's where those two graphs do what? Where they meet, intersect, G-solve. Hey, that's a great idea. G-solve, intersection. You know what? 8.7 years is the sweet spot. If you're leaving it in for more than 8.7 years, Julia, let's say 9 years, then you want the 8%, start out with less, you'll make more. If you're leaving it in for less than 9 years, start out with the 8,500, even though the interest rate isn't as good, you'll make more. Sorry? Yeah, I know, you got the slow ones. Sorry. It'll take a while. But you got both graphs on there, though, okay, yeah? Intersection will take a while. By the way, it's doing some really heavy number crunching. It also, we bought those, I think, in 1999 or 2000. It tells you just in 15 years the chip difference. Okay? So, if she wants to cash out after 5 years, which is the better option?
The early money.
If she's going to cash out after 10 years, which is the better option? We could have found that by hand. Blah. It's nice to use the technology. Is that okay? Well, it turns out you can do a lot of this with technology. In fact, this is important enough that all of you have a financial solver built in. So get your graphing calculators out. I think this one won't be as laggy, I hope. And if you hit the menu button, you want to find the TVM solver. Mine is bottom right corner. I don't know what option yours is. Is it also bottom right corner? Okay. Oh, yours option A, which means it's sitting right about here. Is that right? Okay. So navigate to the TVM solver, please. And activate it. Oh! Which one do you think we want for compound interest problems? F2? What do you think lowercase n is? Number of years. What do you think I% is? Now, and the fact that they said I as a percent, they don't want you to change it to a decimal. They want you to leave it as a percent, I think. We'll double check. What do you think PV stands for? This stands for present value, principal. What do you think payment stands for? Payment, if you're making payments. So this will actually handle making payments during the loan, which otherwise is very, very tough. If PV stands for present value, what do you think FV stands for? Final or future value. Okay? P/Y stands for payments per year or periods per year. Sorry, payments per year, and SLE/Y stands for compound periods per year. We're going to get to that next lesson. But for now, we can use the solver, a screen similar to the one we'll show. So the TI, I think, Zach, you have the TI. Their solver this time is set up very similar to ours. It's the same kind of syntax, except I think ours has a lowercase n right there. Okay? N is the total number of payment periods. Number of years. I is the annual interest rate. PV represents the present value or initial value. See note below. This is going to be important. Unfortunately, this isn't completely clear and simple. Payment represents the payment amount. FV represents the future value. PY represents the number of payments per year. CY represents the number of compounding payments per year. And we don't have end and begin. We have actually, we hit what we want it to find for us. If I want it to solve for n, if I want it to solve for I, if I want it to solve for principal value or the payment or the final, I can have it solve for any one of those. For our calculators, take note of the following. Cash received is positive because it's money entering your pocket. Cash paid, a loan, is a negative. So if you're borrowing money, you'll put a negative in. I think. We'll have to play around with this a bit. Also, P/Y represents the number of payments made to the investment. If no payments are made, then enter this value so that it is equal to the CY value. Can I put a star next to this? This is just a glitch in the software. Our calculator, whether it's TI or Casio, won't accept 0, which it should, but it won't. So, if you're not making payments, then make the PY number the same as the CY number. That's the tricky part, Logan, you'll have to remember. Okay? So the amount, $8,000, is entered as a negative value because it's the initial principal that has been paid to you from the financial institution. Let's do this question. So let's open this up. For number of years, let's make N 5. The interest rate was 7.25%. Leave it as a percent. I think we put negative 8,000 here. Make sure you use a negative and not a subtraction sign. Why negative? Because it's being, the initial principal has been paid to me. It's cash paid out to me or cash paid by the bank. Are they making us extra payments per year, or are they just paying it off to us at the very end? So 0. Final value, just leave as is. We're going to calculate the final value. So for now, we're going to leave it blank. It's being compounded once per year. And so since they're not making payments, we have to make payments once per year, even though that's technically wonky. And if you now hit, once you have those typed in, F5, you should get, there's the loan. There's the $11,352.11. There's the final value. Let me pause. If you didn't get that, now is the time to ask. I'll show you the values that I entered. So do me a favor, folks. Look up, look up, look up, look up. You can scribble this out to find the final value, and instead, to find the final value, press FV, which is function what? I don't know. Oh, look, Mr. Dueck. F5. Okay? By the way, this is really nice because, Mark, here's what it says. If you give me any of the values, I can find the missing one. So maybe you actually are saying, I want to end up with $15,000. I know what I need. What interest rate had I better go find? You can solve for that. Or, I know my interest rate. I know I want to end up with $15,000. And how long do I have to leave it in for? You can do that. So this gives you some very, very powerful tools. Next page. You know what? I'm going to pass on the rule of 72, I think. Nah. To me, it's overrated. Mr. Dueck? Yes, Oscar? I know when I hit exit, there was like a cash flow and an amortizer. Mr. Dueck, what's this first one here? What does F1 say? Geez, I wonder if it's got simple interest built in. Oh. N. I. P. Ooh. You know what? I'm not really sure how this simple interest one works. I think it's easier just to go I equals PRT. If you want to muck around with it and see how this works, and gives you the same answers as doing it by hand, I'll totally let you use the technology on a test. I just never bothered figuring it out because it was as much work to type it in there as it was to type it in and just times. So, okay? What's your homework? Number 1. That's the only simple interest. From here on in, It's compound. And you can either use A equals P bracket 1 plus little I to the N, or you can use the TVM. I don't care. Just check your answers if you're using this one, because there are some quirks and some glitches. 3 is good. 4 is good. 5 is good. 6 is good. Oh, you know what? You're supposed to do numbers 2 to 5 by hand and then do them with the TVM solver. So I'm going to take this back and say, don't do it that way. Do them by hand and then quickly crunch them here. Someone just ripped their workbook? I heard that. Good gosh. 8 is good. 9, I just want you to use the solver. I don't want you to use the rule of 72. By the way, the rule of 72 is a quick way to figure out how long it'll take for an investment to double. And the answer is you divide the interest rate into 72, and that's how many years roughly. You know what? We've got the technology. We don't need to estimate. We can actually crunch it in the same amount of time it takes to estimate it. So do that. Number 9, the right-hand part using the solver. Please make sure you check your answers. Thank you very much.